Okay guys, moving on to video number 2. I'm going to go ahead and first show you the Springboard site as it's set up. You can see the course home will be for any notes. Content is where I am right now. It'll show you what all I have put in here, and so far I've put in one of the videos and the instructions in a Word document for you to be able to take your notes with. Also posted the PowerPoint from Tuesday's class, so just in case you want to review that, you're able to do that. So we'll go ahead and get started with the PowerPoint. Okay, so one of the things that I would like for you to put in your notes is whether or not you think that animals can be superstitious. And so I'd like you to answer that question after we go through this section and tell me, why do you think that animals can be superstitious, yes or no? And so as we continue along in Chapter 1, science is a collection of facts and is a process for understanding the world. So as we go and we look out at the world that's around us, how do we gather information? How do we know that that information is correct? And how do we process that information into a way that we can understand the world that's around us? So we've answered what is science. What is biology? Scientists ask questions and are curious about how the worlds work. They seek out different answers, such as does radiation released by cell phones cause brain tumors? So we can do experiments, we can look at data about brain tumors and how they were caused, and we can find out whether that radiation released by cell phones could cause brain tumors. And for those of you who haven't been keeping up with the news, there has been some questions about whether or not cell phones could cause brain tumors. So that's something that, of course, would be an interesting thing for us to know. We might ask a question like, are antibacterial hand soaps better than regular soap? So should you wash your hands, should you wash them with regular soap, or should you wash them with antibacterial soap? And then finally, does large doses of vitamin C reduce the likelihood of getting a cold? So you can ask yourself these questions, and all of these questions can be answered by science as a process, because we can do experiments to find out whether those things are true, or whether we can test those things and eventually find out if they're true. Here's some other possible questions that are kind of funny. Why is morning breath so stinky, and can you do anything to prevent it? So finding out why morning breath is, why it's caused, what it's caused by, and if you can do anything to prevent it. Most of us have that when we wake up in the morning. Why is it windy on streets with tall buildings? So if you've ever been to a place that has skyscrapers, or really even just walked around campus here, when you're next to some of the really tall buildings like the Goodyear Polymer building, it's really windy next to them. Does taking aspirin before drinking alcohol lead to faster intoxication? So you could test and find out if that's true or not. So one of the things that you notice about each one of these things is that it's possible for us to test these things and find out whether or not they're true. So science is not simply a body of knowledge or a list of facts to be remembered. It's not like science is just like, what is this? What is that? What is this organ? What is that organ? It's actually this intellectual activity where we go out and we observe the world around us. We come up with these thick, rich descriptions of what we know and what has happened. We can go through experimentation in order to find out whether things have causes and results. And then eventually we can come to some kind of explanation of that natural phenomena based on science, based on what we can find out. So scientists are always asking the following question, which is, how do we know that that is true? That is the one single question that underlies just about all scientific thinking. How do we know that that is true? What kind of facts, what kind of experiments, what kind of things do we have to prove that we know one thing is caused by another thing, or one thing happened, or an experiment worked? So we're constantly asking ourselves that. If you have ever looked at packages of certain things that they sell in the drugstore, like this is a pill that's sold in places like Walmart or Walgreens, that you put into your drink, and it's supposed to be specially formulated so that you don't get sick. And it actually said you will not get the flu if you take this pill dissolved in your water and drink it. This school teacher came up with it and said, when I take this, I don't get sick. And so they found that other places where people usually get sick, where they're surrounded by lots of people who are sick, like in airplanes, in offices, in schools, in restaurants, health clubs, theaters. This was a really popular item that sold really well for a long time, and people really believed that that they would not get sick if they took this. So we ask ourselves, can we really trust the packaging claims made by companies like this? They say, we went through a clinical drug trial. We came up with evidence to prove that this airborne worked. The CEO actually said to people who questioned the science behind it, people are not really scientifically minded enough to be able to understand a clinical study. And people started to question, well, why would the CEO say that? You don't have to be at the mercy of cranks or charlatans or advertising or slick packaging when you have science on your side. You learn what exactly it means to have scientific proof of something, and you can learn what it means to think scientifically about something. Scientific literacy is being able to think scientifically, to know how the knowledge that we gain helps us to make wise decisions. It has become even more increasingly important in our lives because science is so important. We have tons of medical decisions, tons of healthcare decisions, tons of decisions about our environment, decisions about our food, decisions about vaccinations. Science is becoming such a big thing that we need to know whether or not the things that we read or the things that we're going to do are grounded in science or not. So literacy in biology matters and is very essential to being able to live in this 21st century. Biological literacy is the process of using scientific inquiry to think creatively about real-world issues, then being able to communicate those thoughts to others. This means it's not just a Facebook discussion or a Twitter discussion about whether organic food is good for you or whether you should vaccinate your kids. It's actually being able to do the research and understand what scientists say and how they've put together studies to either prove or disprove that something is good for you or something harms you. So having biological literacy helps you to be able to integrate this scientific inquiry into your life. These are the heads of some of the magazines that have come out over the last couple of years. One of the big questions in the news right now is, do vaccines cause autism? And some of you may have heard that vaccines do cause autism. It's actually been proven that there is no link between vaccines and autism, but a mother of an autistic child often believes that because the disease showed up right after she vaccinated her child, that is the reason behind it. But what scientists have found is that based on the time of year and the age that we give vaccines to kids and the age that autism shows up, that they are not actually linked to one another. But as I said, many of you may have actually heard that. We've heard questions about global warming. We've heard steroids. We've heard questions about doing DNA tests and how people can actually be released from prison because they found out that the person didn't commit a murder or didn't commit a rape. And so it's really important that you be able to read these stories with a critical eye and actually understand whether the science behind them is